Okay, here are the work solutions for paper 2. Question 1, we're looking at the Venn diagram. First thing to fill in is the students that study both, so that is the 20 students in the middle there. Then we've got 13 studying French but not Spanish, so they're going to be on this side, and then a total of 43 studying studying Spanish, so that is this whole circle. We've got to take away the 20 that are in the intersection with French, so that is going to leave 23 there. And then we've got 60 in total, so the remaining students that don't study either French or Spanish are going to be on the outside. So we can do 60, take away these three, will give us that number. So adding these three up is going to give us 33 and then 56. So we've got 4 on the outside. Probability that they study neither French or nor Spanish then is going to be these 4 on the outside. So that's 4 out of 60. And simplifying that down gives us 1 out of 15. Question 2, we are doing the transformation from P onto Q. So we're going that way. We can see that it's a rotation because the triangle has been rotated through by some angle to get from P onto Q. What we want to decide is where is the midpoint of this rotation. So we can get out some tracing paper. It's a good way to do this. Draw the shape, then put on a different point and see if we can find that. But hopefully we can see that the center point of the rotation is going to be 0, minus 1 there. Now we've got to decide how far the rotation is. Well, looking at these two lines which line up with these, we can see that that is 90 degrees. We're going anti-clockwise, so the full description here is going to be a rotation 90 degrees anti-clockwise about the point 0, minus 1. To get the 2 marks, we need to say it's a rotation 90 degrees anti-clockwise and with the point as well. Question number 3, looking at the scatter graph. So this is to do with the number of children attending a pool over a 10-day period, and we've got the temperature each day as well. One of these days is an outlier on the scatter graph, so that's going to be one of the points that doesn't line up with the general trend of the data. General trend looks like it's going to have a line of best fit here, so it's this point down here which is our outlier. Possible reason for that, it could be a number of things. We could say it was a school day, something like that. Anything reasonable there is going to get you the marks. Type of correlation, well, if we draw on the line of best fit approximately, it's going to look like that, and that is a positive correlation. Okay, final parts on this question are asking what is an estimate for the number of children going to the paddling pool on this day. So the temperature was 19. If we go back to the graph, we're going to look at where the temperature is 19 and then go across to find the number of children there. So on my graph here it's 18. You do get a bit of leeway with that depending on where you drew the graph. So look at the mark scheme for that. It would not be sensible to use this graph to predict the number of children going to paddling on a day when it was 13 degrees. Reason why, we go back to this. So 13 degrees is down here. If we were to use our line of best fit, I'm just going to draw it in red to extend it out. It's going to go down here. So for what we've got for 13, it's down here, it's a negative number, which wouldn't make any sense. So that would give a negative frequency.
Question 4, we are looking at finding the shaded part of this shape. What we're going to need to do is to cut this into some easier shapes that we can work out the area and then break it down to get that part. So what I'm going to look at first is these two rectangles here. To find the areas, this one's nice and straightforward, but we need to find the lengths of this one. So what we need to do is label some of these sides to start with. First off, that 6 there has come from the 4 plus the 2. And then we're going to label this one x, which means this one down here is x plus 3 from what we have at the top. So the perimeter of this is x plus 3 plus 4 plus x plus 2 plus 3 plus 6. And that equals 28 from the question. Simplifying this down then, we get 2x. And then we've got 7, 9, 12, 18, so plus 18 equals 28. Take away the 18 gives us 2x equals 10. So x equals 5. So we've got 5 there and we've got 8 at the bottom here. So that 8 and that is 5. So we can now find the areas of these rectangles. So the area of the whole shape is going to be the area of this bottom one, so that is 4 times 8, and then plus on the area of the top one, 2 times 3, so that's 32, plus on 6 equals 38. That's the area of the whole shape. And then to find the shaded part, we're going to need to take away these two triangles. So that is going to be the area of A, F, E. And we're going to use half base times height here. So 4 times 2 divided by 2. 4 times 2, 32 divided by 2 is 16. And then the area of the other triangle, so that is CDE. We've got 3 times 6 here, and then divided by 2. So 18 divided by 2 is 9. So that leaves us with the area of the shaded. It's going to be our total area, so 38 minus 16 and then minus 9. 38 take away 16 is 22, take away 9 is 13, with our units is meters squared. Okay, question 5, we have some simultaneous equations. So first thing we do is we're going to label these equations. Next, we need to get one of our variables with the same number in front. So we can either get the x's the same, but I'm going to focus on the y's here, simply because we've got a plus and a minus here. So it's going to make cancelling out a little easier in a second. So what we can do is we can times that first equation by 5. So that will give us 20x plus 5y equals 50. And that second equation we don't need to change because we've got the 5 there. So that will be x minus 5y equals 13. Now if we add together these two equations, the plus and minus here are going to cancel down to give us 0y. So what we end up with is 21x equals 63. And then dividing by 21 gives us x equals 3. So we get x equals 3. To find y, we need to sub in x equals 3 into one of these equations. So sub in x equals 3 into either equation will work. So let's say into 2 is going to give us 3 minus 5y equals 13. Take away the 3 gives us minus 5y equals 10. Divide by minus 5 gives us y equals minus 2. So there we have our answer. As a quick check, we can sub both of these two values into the top equation. So we're going to sub x equals 3 and y equals negative 2 into 1. So that is 4 times 3 plus minus 2, which is 12 minus 2, which equals 10. As it should, so that is all good. Smiley face. Okay, next up we are filling in the table for this. So we need to sub in these values into this equation. Now we are on a calculator paper, so we can use our calculator for this. And since you have it, why not? So 3 divided by 0.5 we can see is 6. That's going to go there. Summing in the other values a little bit easier. 3 divided by 3 is 1. 3 divided by 5, let's chuck that in. So 3 over 5. Pressing our FD button to get that as a decimal is 0.6. 3 divided by 6, another easy one, is just 0.5. So these are the values we have. Then we need to plot those. So first one is going to be there. That's our 0.5 to 6. There 1 to 3. 2 to 1.5 is there. 3 to 1. 4 to 0.75. 5 to 0.6. And 6 to 0.5. So we have this graph joining up those points looking like this. Hopefully yours a little bit neater than that. And that is it. For this question, we are looking at the comparison in price between different countries for this CD box set. It's going to be sensible to get everything in pounds because that is what these two comparisons or exchange rates are given in. So let's look at the USA to start with. We've got in dollars 134.99. To get that into pounds, we need to divide by our dollars here to get it to pounds. So we're divided by 1.43. So we're going to get our calculator out. We are doing 134.99 divided by 1.43. So putting that in gives us 94 pounds 40. So already we can see that that is cheaper than in the UK. Let's look at Germany. So in this case we've got in euros, we want that in pounds. So in this case we're going to take our 139.99 and we're going to times it by the pounds, so 0.73 to get that to pounds. Again, get our calculator, so 139.99 timesing by 0.73 and it gives us 102.19 all in pounds. So we can see that the US is cheapest. Okay, Gina lives in the UK. Why might the USA not be the cheapest or the best country to buy from? Well, it's a long way to go. She's going to have to pay for delivery, import taxes, and things like that. So may have to pay lots for delivery. Good. Question 8, we've got two different ratios, A to B, B to C, and we want this as the three parts all together in one ratio. So what we need to do is get this B value to be the same in both. So we've got 5 and 3 for each of those. We can see that that goes into 15 for both. So this is our B in the middle. And from this one, we're timesing by 3 to get 15, so we have to do 8 times 3 for A. 8 times 3 is 24. For this one over here, we're doing 3 times 5 to get 15. So for the C value, we've got to times that by 5 as well, which is 20. And that is going to be in the simplest form because nothing divides all three of these. Question 9, we're looking at a bit of standard form. So we want to write this as an ordinary number. If this was just 3 times 10 to the 4, we would have 3 followed by 4 zeros. But that 6 there is going to take up the place of one of the zeros. So we're going to have 36,000, just the 3 zeros there. This next one, we can put this into our calculator to work it out, but let's see if we can simplify it a little bit before we do that. So just considering these two numbers, we've got 2.8 divided by 4.7, and then considering the standard form parts, so we've got 10 to the minus 2 here divided by 10 to the minus 5. So if we're dividing with our indices, we're going to take away the indices here. So that's going to be 10 to the minus 7 overall. And then we can use our calculator. So again, our calculator there. If we do our 2.8 divided by 4.7, and then getting the decimal, that's going to give us 0.5957, and then timesing by 10 to the power of -7 is going to give us 5.96 times 10 to the minus 8, and that is in standard form. Okay, we are trying to decide whether x and y follow the relationship that y is directly proportional to x, y is directly proportional to x squared, or y is directly proportional to x cubed. One way we can do this is to test each of these and see what works. So what we can look at is if it was directly proportional y to x, then we're going to have the same multiplier for each of these. To find the multiplier, we can do 400 divided by 5. 400 divided by 5 would give us 80, and the same for this one. So 576 divided by 6. We can get our calculator for that. That is 96. So those aren't the same there. It's not multiplying by the same value, but different things here. So what we then need to look at is what happens if we do x squared. So we're going to do 400 divided by x squared. So 400 divided by 25, 400 divided by 25 is giving us 16. And let's do the same for this one. So 576 divided by 6 squared, or 36. 576 divided by 36. And that equals 16. So what we get is the same value here. So they are, we get the relationship y is directly proportional to x squared. For the formula of y in terms of x, well, we've actually worked it out in this part, because we've got y is directly proportional to x squared, which means y equals kx squared. Now this value of k is this value that we got here, because that is what we're multiplying by to find y from x. So y equals 16 x squared for the formula. This question here, we are looking to find the value of x when h equals 4d. So instead of h there, we are going to have 4d. Because this is a right angle triangle, we're going to be using a bit of SOHCAHTOA. Okay, so for this, we need to label the sides first. There's our x, so this is the opposite over here. This is the adjacent down here. That's our hypotenuse, but we have no information about that, so we're not going to use it. So we have O and A, which means we are using TOA. So the TOA formula is tan x equals opposite over adjacent. In this case, that is tan x equals 4d over d. And this is going to simplify down. So it gives us tan x equals just 4, because the d's cancel out. And then we can do our inverse tan. It's going to be of 4 there. Putting that into our calculator. So we have tan to the minus 1 of 4 in degrees gives us 75 or 76.0. 76.0. So that is our value of x. For part B, we are looking at some different instructions. So if the angle is moved so that it's slightly less, that means the value of d is going to increase, and that means the value of the height will decrease slightly. So it will decrease slightly. Okay, here we have a sequence. We are told it's a quadratic sequence. So we are going to be looking for an n squared term in this. With any sequence, it's useful to look at the differences between the terms to decide what's going on here. So we've got a difference of +5 there, then we've got +7, and then that is +9. The differences here is 2 and 2. So because this is 2, that tells us we're going to have an n squared. That's just one n squared for this. So next we need to decide what else is going to be on the sequence. So what we do is if we label our sequence Tn, we're going to look at what n squared does. So n squared is 1, 4, 9, 16. That's our square numbers. And then we're going to do our sequence take away n squared. So we are doing 3 take away 1, which is 2, 8 take away 4 is 4, 15 take away 9 is 6, 24 take away 16 is 8. So we get this new sequence, which is just a linear sequence. You can see it's linear because the differences are all the same. We want to work out the nth term of this. So this has a difference of 2, which means it's 2n. And in fact, that is all it is because we don't need to add anything on. So because our nth term for Tn, we took off n squared, and that gives us 2n. For our nth term for Tn, it's going to be n squared plus 2n. For a different sequence, we have 2 to the power of n plus 5. We want to show that 36 is not a term for this. So what we do for that, so we make it 2 to the n plus 5 equals 36. So that means 2 to the n equals 31. Now here, this cannot give us an answer for n because 2 to the power of n follows the sequence 2, 4, 8, 16, 32. It's the powers of 2 is never going to equal 31. So n will not be a whole number. This question is to do with capture and recapture. So Alex is catching some ducks. On the first day, he puts 30 tags on out of the total number of ducks, let's say X. So that is on the first day. On the second day, he catches 40 and 8 of them have tags on. So we're going to say that the tagged ones, 8 out of the 40 that he catches, is the same fraction or an equivalent fraction to what he had on the first day. Then what we need to do is solve this equation. To do that, we can times by 40, which is going to give us 1200, times by the x is going to give us 8x, and then we can divide by 8 to get our x value. So that gives us x equals 150. For part B, he's assumed that none of the tags fell off during the night. If he is wrong, that means his estimate here is going to be an underestimate. So he will have underestimated. For question 14, we need to know our index rules. The first one to look at is in this first part of the equation. What we want is we want 3 to the n. So that is getting rid of the negative here. A negative on an index does a reciprocal. So we're going to put that to the other side and make it the reciprocal there. So it's 1 over 0.2. 1 over 0.2 on our calculator, we can see what that is going to equal. 0.2 equals 5. So that is 5. So we get 3 to the n equals 5. The next thing we can do is with this second part. What we're going to say there is that this is the same as 3 to the n to the power of 4. Now the reason we can do that is if we expand out these brackets, it goes to 3 to the 4n, because these get times together. And we can change the order of those because the order of multiplication doesn't matter. So that is what this thing equals. What we have worked out in the first line here is that 3 to the n equals 5. So this is 5 to the power of 4. On our calculator, 5 to the power of 4 is 625. So that is our answer for this. Question 15, we need to work out the percentage of the area of the circle that is shaded. So to do this, we are going to need to work out the area of the sector here. So that is from A to O to B, including the curved part there. We're going to need to work out the area of the whole circle. We're going to need to work out the area of the triangle. So let's start off with the circle. Area of the circle. That is going to be pi r squared. So pi, and then our radius is 30 and squared. That's going to give us 900 pi. Let's leave it in terms of pi for now. For the area of the sector, so that is the sector AOB, we're going to take the area of the circle and we're going to times it by the fraction of the circle we have. So that is our 80 degrees out of 360. Again, leaving our answer in terms of pi, so we can do 900 times by 80 divided by 360. So that gives us 200 pi for the area of the sector there. Also need the area of the triangle. So area of the triangle, and again that's AOB. That is going to be from the cosine, not the cosine rule, from the area of the triangle formula. So that's half AB sine C. In this case, our A and B are the two sides either side of the angle. So that's these two here. So that's a half times 30 times 30, because they're both a radius, and then times by sine of our angle, which is 80 degrees. Putting that in on our calculator then, we have 0.5 times by 30 times by 30 times by sine 80. So that gives us 443.16. Okay, so to find the area of the shaded, we are going to do the area of the sector, take away the area of the triangle. So that is our 200 pi, take away 443.16, using the value from our calculator. So that is 200 pi, take away the answer we have there. That is 185.15. 5 something. So that is the shaded area. We want the percentage of the area that is shaded. So percent shaded is that area. So it's our 185.155 using the answer from the calculator out of the total area of the circle, 900 pi. And then to get the percentage, we're going to times by 100. So we've got our 185 there. We're going to do that divided by 900 pi. and then times by 100 to get the percentage, which gives us 6.54%, or 6.55 rather, looking to 3 significant figures. Okay, this question we are looking for the mistakes that Helen has made with her inequalities here. Now she's actually made mistakes on all 3 of these lines, but let's go through each of them and point out the mistakes. So on equation number 1, x plus y is less than or equal to 6. Well, that should cross through at 6 on each of our axes, whereas she's done it through 7. So x plus y is less than or equal to 6 should go through. Writing down the coordinates, it should go through 0, 6 and 6, 0. So incorrect there. Next one is our y is greater than 0. For y to be greater than 0, we are looking at anything above the x-axis. Whereas here she has used the y-axis, which is x is bigger than 0. So she has used x is bigger or equal to 0 and not y is bigger than or equal to 0. That is enough to get our 2 marks, but let's write down the third reason for this equation being wrong as well. So y is less than or equal to x plus 2. Now the line is drawn correctly. It's got a gradient of 1 and a y-intercept of 2. But this is less than or equal to x plus 2. So that means we're going to be looking at below this line, so anything on this side of it, rather than this part over here, which would be greater than. So she has used y is greater than or equal to x plus 2, and not what is written, which is y is less than x plus 2, less than or equal to x plus 2. Okay, for this question here, we are trying to find the area underneath this curve between t equals 1 and t equals 4. To start this off, what we're going to do is draw the lines on for those 2 values. There's t equals 1 and there is t equals 4. To find the area underneath this, we're asked to use 3 strips of equal width. So because this is 3 across, we can cut the strips to be have a width of 1 like that. Then what we're going to do is we're going to join up where these points meet on the curve. So we get these shapes here. These shapes we can work out the area of, because these are just trapeziums, because they have a pair of parallel sides and then some sort of length between them. So to work out the area of a trapezium, we're going to do a plus b divided by 2 times by the height. A and b are the parallel sides, and the height is the distance between them. So in this case, the height of all 3 is 1. To find out the values of a and b, we need to read across on our graph to get the speed. So from here, going up to the graph and going across, that is 3.6. This one here, reading across there, that is going to be 6.4. From here, going across, we get to 8.4. And then that top one, moving across there, gets us to 9.6. So do use a ruler there just to check those values are accurate. Then we can apply our area of the trapezium to find the area of each of these. What I'm going to do is label them A, B, and C so we can show clearly which one we're finding. So the area A is going to be 3.6 for the value A plus 6.4 for the value B, divided by 2, and then times by 1 for the height. So I won't include that times by 1. So we can work that out. We can use our calculator. We're going to do 3.6 plus 6.4, and then divide that all by So like that on our calculator, and we can see that that gives us 5. So this value here equals 5. Area B is going to be 6.4 for the first value plus 8.4 for the second divided by 2. So we can change this 3.6 to 8.4. That gives us 7.4. And then the area C, we're going to do 8.4 plus 9.6 all divided by 2. Again, times by 1 for the height. So on this, changing this one to 9.6, and that gives us 9. So the area is going to be those three values added together. 5 plus 7.4 plus 9. 5 plus 9 is 14, plus on 7.4 is going to be 21.4 for the area. This is just an estimate because there's going to be some bits missing off from that. Okay, on to part B for this question. What is this answer actually representing? Well, what we're looking at is a time and speed or velocity graph. So the area underneath that shows the distance covered between t equals 1 and t equals 4 in meters. So where we're getting the marks for that is saying that it's the distance and that it's in meters. Part C, we want to explain whether this is an underestimate or an overestimate. Well, this is an underestimate. And the reason for that is if we look back at the graph, we can see that there are small parts just here, here, and there's a very, very tiny bit there that are missed off when we do the trapezium. So the reason is an underestimate, as the trapezium is under the curve. Okay. Question 18, we are looking at the different combinations we can have for head girl, deputy head girl, head boy, and deputy head boy. We're told there's 95 girls, so that means we have 95 choices for head girl. Once we've chosen the head girl, there are only 94 choices for the deputy. So what we can do is if we multiply those, that's going to give us all of the combinations for head girl and deputy head girl. For the boys, we've got 87 boys, and then there's going to be 86 choices for deputy once we've chosen the head boy. So multiplying both of these out is going to give us the combinations for head girl and deputy head girl, and then head boy and deputy head boy. To get all four mixed together, what we need to do is multiply those four numbers together. So if we get our calculator out again, we're going to do 95 times 94 times 87 times 86. And we can see there that that is 66,814,260. So 66,814,260. Quite a lot of different choices. For this question, we need to find the equation of the line L, which is perpendicular to the line we have from these 2 points and goes through the point M. So quite a lot going on here. What's going to be useful here is to have a little sketch of the information we've got and then see if we can interpret what we need to do. So we've got the point minus 97 going to be there, and then 11, 12 somewhere up there. So this is the points P and Q. And we have got the point M somewhere along this line, such that it's in the ratio 2 to 3 along the line. So what we're going to do here is, if we draw a triangle, we can look at what is the length here, what is the height here, and then use this ratio to cut this up to find the point M. So for the length along the bottom, we're going from -9 up to 11, so that is 20 across, and then we're going from 7 up to 12, which is 5 up there. So to find the point M, we can look at the x value to start with. That is going only 2 out of 5 along from here. So what we can do is 2/5 times by the 20, which is going in the x direction, and then add that on to the starting point with the x value. So that's going to be the -9 there. So working that out, 2/5 times 20, we can put that in on our calculator or work it out, is going to be 8, plus -9 is going to give us -1. So that is the x value for our M coordinate. We need the y value as well, so we're going to do the same thing, find 2/5 this time times by the 5, and then add on our starting point, which is the 7 there. So this one, that's going to be 2 from here, plus only 7 is 9. So our point M is -1, 9. Next thing we need to know is the gradient of P to Q. So the gradient of PQ. To do that, we need the change in Y divided by the change in X. So that is 5 divided by 20, and that's going to simplify down to 1/4. From here, we've now got a coordinate and we've got the gradient. We are interested in the perpendicular line. So the perpendicular line is going at 90 degrees to the line PQ. And we know that the gradient of a perpendicular line is the negative reciprocal of the gradient we have. So the gradient of L is going to be the negative reciprocal of this. So negative to start with, and then reciprocal means we're flipping over that fraction. So 4/1, or just 4. So our gradient of L is -4. Now we can use our equation of the line. So we can either use y equals mx plus c, sub in our value of m, which is our gradient here, sub in the points for x and y here, and work out c. Or we can use y minus y1 equals mx minus x1. Either of those two is going to give us the same answer as we work this through. My preferred one is this one here, but we'll work through both and compare them just to check that they both work. So subbing the values into this one, our y value is the y value of the coordinate, which is 9. M is -4 times by x, which is our -1 here, so we're timesing by -1, plus c. And c is what we're trying to work out. So simplifying this, -4 times -1 is 4 plus c. That gives us c equals to 5, taking off the 4. So what we get is the equation is y equals -4x plus 5. On this side, if we work through just to check that we get the same thing, we're going to do y take away the y value, so y take away 9 equals m, which is -4, and then x, and then x1 is the x value, so it's -1. Expanding this out gives us y minus 9 equals -4x. Minus and minus here makes +1 times by the -4 gives us -4 there. And then rearranging this gives us y equals -4x. Adding on the 9 gives us +5. So same answer either way around. The reason I like this one just slightly more is we don't need to work out the value c. We're just plugging into this and then simplifying down to get our solution. Either is fine though. For question 20, we are given this equation, y equals pq to the power of x, which gives us this graph, which has a exponential shape. So it's increasing in gradient as we go up, getting steeper and steeper. We're also given a few points on this. So what we can do with these points is we can put them into our equation and find out some of these values. So the key points to start with are going to be the ones where we have both the x and the y. Starting with this first one with 0, that's going to be quite helpful to work something out. So if we sub these in, we're using the equation y equals pq to the power of x. We've got our x and y here. So if we sub in y equals 5, then we've got p and then q to the power of 0 for x. Now we know anything to the power of 0 equals 1. So this is 5 equals p times 1, which just gives us p equals to 5. So that means we can change our equation now, and we can make it y equals 5q to the power of x. Then we're going to use this next coordinate and sub that in. So at 405, subbing in 405 for the y value, and then 4 for the x value is going to give us this. We need to work out what q is from here. So we can divide by 5. 405 divided by 5 is 81. And that is q to the power of 4. From there, we can use our calculator to do the fourth root of 81 to work out q. What that's going to give us is q equals to 3. So the equation we've got now is y equals 5 times 3 to the x. And we want to work out the value of k, which is when x equals 2. So we're trying to work out the y value essentially. So y equals k, and then to find that value we need to sub in x equals 2. Then we can work that out, so that's 5 times 9, which gives us k equals 45. Checking whether that's realistic, just looking at our graph here. The y values are 5 here and 405 here. 45 there is going to be towards close to the 5 there, so that is definitely realistic. It's not like we've got something that's beyond 405 or less than 5. So that is good. Final question on this paper is to do with vectors. So we've got the vectors O to A is A, so that is this one here. O to X is to B, so O to X is to B, and that's right on the arrow swinging in the direction. And then X to B is B, so this one is B. And we want to prove that X, Y, Z are on a straight line. So from here to here, all the way down there is a straight line. So let's draw that in so we can see what we're dealing with. Okay, so what we're going to need to do then is find the vector from X to Y, and then the vector from Y to Z, and notice the relationship we have there. So going from A to B to start with is going to help us to find the vector here. What we have got is Y is the midpoint of AB, so we're going to use that property as well. Starting off though, let's go from B to A. In fact, the other way around. So we're using this length there. So to get from B to A, we have to go back along the vectors we have here, and then along that vector there. So that's going to be minus the B here, minus the 2B there, and then along A. So that is minus 3B plus A. Reason we've got that is then we can look at the vector from B to Y, which is going to be half of this. So it's going to be minus 3 over 2B plus a half a. Once we've got that, we can work out the vector from x to y, which is going to be from x down to b and then along to y. So that is b plus what we've just worked out. So minus 3 over 2b plus a half a. This simplifies. We've got 1b and then take away 3 over 2b or 1.5b, which is going to give us minus a half b, and then the a still a half a. So that is from x to y. We also need from y to z. So to get from y to z, we're going to go back along this one towards b, and from b we're going to go to o, o to a, and then a to z. A to z, because we know that a is the midpoint from o to z, this part is a, which means this part is also a. So using that, we can work out from y to z, y to z, writing this as the vectors, is going to be y to b plus b to o plus o to z. So y to b, we've worked out up at the top here, b to y. So y to b is this, but in the other direction. So it's going to be with negatives. So that negative becomes positive. This one becomes negative. O to b is minus 3b. And then O to z is 2a. Simplifying this down, so 3 over 2b take away 3b. Think of it as 1.5 take away 3. It's going to give us minus 1.5 or minus 3 over 2b. And then this one here, we've got 2a minus a half a is going to give us 1.5 or 3 over 2a. What we now notice is that this is just 3 times what we've worked out at the top. So this is 3 lots of x to y. We now have enough information to prove that x, y, z are on a straight line, because we have that they are both multiples of the same vector, and they both share the point y, so that is a common point there. So we just need to now state that. So x, y, z is a straight line. As yz equals 3xy, and y is a common